For number 5, it says an annuity provides a payment of N at the end of each year for N years. The annual effective interest rate is 1 over N. What is the present value of the annuity? And to conclude this answer, we get this is the formula for this, and this is the formula using this formula, and you insert the I here, and then you calculate until you get this. For number 7, it says to find a angle 8 if the effective rate of discount is 10%, and you use this formula, and then you insert the D equal to 0.1 here, and then you get this 5.6953. For number 8, it says find the present value of payments of $200 every 6 months, starting immediately and continuing through 4 years from the present, and $100 every 6 months thereafter through 10 years from the present, if I2 is equal to 0.06. And we have to draw the timeline, and as you can see, this is the timeline. And this is every 6 months pay, and this is the timeline, and you can see it from here, this, and this you get I 0.03, and you get the equation of value of 200 A angle 9 plus 100 A angle 13 times V9, and by that you insert the value inside here. This is 1 plus I, from here 1 plus 0.03, and then you get $2,389.72. For number 9, a worker age 40 wishes to accumulate a fund for retirement by depositing $3,000 at the beginning of each year for 25 years starting at age 65. The worker plans to make 15 annual withdrawals at the beginning of each year. Assuming that all payments are certain to be made, find the amount of each withdrawal starting at age 65 to the nearest dollar if the effective rate of interest is 8% during the first 25 years but only 7% thereafter. First, we draw the timeline, and you get this. You put the drawer, and this is the I, 0.08. And this is the equation of value. We use this formula, and then we insert it here. Then we get $236,863.25. And then using this formula, we insert the value, and then we'll get K. But this is the withdrawal. We get the K, which is $24,304.96. For number 17, it says find the present value to the nearest dollar on January 1 of an annuity which pays $2,000 every 6 months for 5 years. The first payment is due on the next April 1, and the rate of interest is 9% convertible semi-annually. Okay, first, we draw the timeline, and you get this. And then if we find the I, and we'll get the equation of value of this, 2000 A angle 13 times 1 plus I, and insert the value inside here, the I here, insert the formula here, and then we'll get $16,178. Number 30, a beneficiary receives a $10,000 life insurance benefit. If the beneficiary uses the proceeds to buy a 10-year annuity immediate, the annual payout will be $1,538. If a 20-year annuity immediate is purchased, the annual payout will be $1,072. Both calculations are based on an annual effective interest rate of I. We have to find I, and by that we draw the timeline of here. by 10-year annuity will be here 1,558, and then 20-year annuity immediate is purchased. The annual payout will be $1,072, and then the equation of value is this 1,538 and A angle 10, 1,072 A angle 20, and then we insert the formula, and then we insert the value, and we calculate it, and then until we get interest 8.69%. For number 33, it says find the present value of an annuity immediate for 5 years. For this, I angle 5, if I 5 is equals, and okay, this is the equation here for T equals to 1, 2, 3, 4, 5, and then A is says to find yield curve method. Wait, first we draw the timeline here to find the present value, and then we use this formula, A angle N. This is the formula, and first we'll find the I each year, 1, 2, 3, 4, 5. This is for I1, 0.06, and so on, and then we insert the value inside the formula, and then we'll get 4.1543 dollars. This is the present value. We can also conclude it like this: B1 plus B2 plus B3 plus 4, B4 plus B5. This is the same as this. For B, it says to find portfolio method, and this is the formula, and you can also conclude it by this: B1 plus B1, B times B, okay? And then we insert the value from this value inside here, and then we'll get the present value using portfolio method by $4.0118. For number 40, it says at an annual effective interest rate of I, both of the following annuities have a present value of X. A 20-year annuity immediate with annual payments of 55, and then a 30-year annuity immediate with annual payments that pay 30 per year for the first 10 years, 60 per year for the second 10 years, and 90 per year for the final 10 years. Calculate X. And by this statement, we'll get this equation of value: 55 A angle 20. And then we insert the value inside here, the formula, using this formula, and then we insert here. And then for this statement here, we'll first draw the timeline, and then we'll get this. And then this is the equation of value: 30 A angle 10 plus 60 A angle 10 V10 plus 90 A angle 10 V20. And by that we insert this value. This equals to this. And then we'll calculate it until we get V10 is equals to V to the power of 10 equals 2.5, and this V we insert this formula of V1 plus I, negative to the power of negative 10 equal to 2.5, and then we'll calculate it all until we get interest of 0.0718, and then we can find the answer of this equals to $574.60. So the present value of X is this, $574.60.